Okay, so quick history of the Earth here. First, the Earth was formed. It was a whole bunch of lava that started to cool and form rocks on the crust. Then those rocks got kind of broken up into little tiny pieces, like you see here, by wind and water and things like that. Then all those little pieces got stuck together and formed new rocks, and then those rocks get kind of buried back down into the melty part of the Earth and get melted again. You may know this as the rock cycle. Don't forget that red slides are where you have to take notes. You should have your notes handout ready to go. Don't forget to look for the owl and let me know where he is. And remember to fill in all of this stuff that you see here. Ah, the rock cycle. You know all about the rock cycle. You've learned about this before. Let's see. Can you name them? What's that one? That's igneous. That one is sedimentary. And that one is metamorphic. How'd you do? Pretty good? All right. So, the rock cycle is how one rock changes into another rock, and it's actually a little bit more complicated than what you might have learned about before. So we got to fill in a little bit more here because, well, we're in 8th grade now, so we got to learn the real story here. All right, so you guys know that it all starts off with minerals, right? So we have the elements that the universe is made out of, and those elements all kind of come together to form minerals, and minerals, when they get mixed together, form rocks. So minerals become rocks. So the early Earth kind of looked like this, and the first phase of this is the idea that we had a whole bunch of lava on the Earth, that stuff. And once it kind of bubbled up to the surface and things calmed down on the Earth a little bit, it started doing this right here. It started cooling off and hardening and forming a solid substance, and this is the first rock. These are the first rocks on Earth, all of that hard stuff right there. So that forms our first rocks, and those are what we call igneous rocks. So when you look at igneous rocks, I want you to look at a few different basic characteristics of them that we want to try to identify here. One of the things are going to be the crystals. So you can see some crystals right there. You can see some other crystals right in there and in there. Those are our crystals, and that tells us a lot about the rocks. We can also see different colors, right? We have this color here, different colors within one rock, some very different colors going to some other rocks. Those are some of the main things that you want to look at when you look at igneous rocks. So igneous rocks are basically just cooled lava. All right, next up we have sedimentary rocks. So sedimentary rocks, some of the characteristics that you want to look at for sedimentary rocks are these layers. You tend to have a lot of layers with sedimentary rocks. And we want to look at the size of the sediment. All of these things tell us a story. They are like detectives' clues that tell us a story about how that rock was formed, what the conditions were like, what the atmosphere was like, what the climate was like, whether it was a desert or whether there was ice over it or whether it was at the bottom of an ocean. All of those things are things that we can figure out by looking at these different things about these rocks. And last but not least, we have metamorphic rocks, and the thing to look for in metamorphic rocks are these bands. Notice that these little bands, or what they call foliations, are different than the layers that I showed you in the sedimentary rocks, right? These are all kind of warped and swirly. They remind me of when you take different colors of Play-Doh and kind of smush them together and you get all these little swirly different colors, okay? And it's kind of interesting because that's really how metamorphic rocks are formed. It's very similar to the idea of taking Play-Doh and kind of swirling it and smushing it all together. All right, so what are the processes that happen that make these different types of rocks? Well, once you get your igneous rock, it needs to go through weathering and erosion. And we're going to talk a lot about that stuff, but weathering and erosion is basically the way that the earth kind of breaks down these rocks into into smaller pieces. So here's a few different examples for you. All right, we have a stream here that is basically cutting away at the soil and rock beneath it, and you can see how that stream changes, and that stream is going to be moving some different little pieces of rock down the stream to the bottom. We have wind over here. That's a pretty nasty little windstorm there. We have tectonic activity where tectonic plates actually move around and bend and deform rocks. And we have the freezing and thawing of the earth. And all of these things all reshape the earth. And one of the great examples of this is the Grand Canyon. One of the best examples in the entire world of this idea of the earth being reshaped. Almost every one of these single processes, not almost, every one of these single processes here is responsible for what you see in the Grand Canyon. All of these different processes, freezing and thawing, wind, water, plate tectonics, all of that stuff came together to form the Grand Canyon over millions and millions of years. So basically, when you think of weathering and erosion, what I want you to think of is the idea of breaking rocks into little pieces, like this guy's doing right here. He's basically doing some weathering, and then the rocks get moved to a different place. They get kind of taken down a river and deposited in the ocean or something like that. That's erosion, moving those little pieces of sediment from one place to another place. This is a good example, this picture that you see here. The waves constantly crashing on these rocks and taking these big, huge rocks here and making them into little teeny tiny rocks like these guys down here. All right, so after we get weathering and erosion, this creates sediment. Sediment like this. And remember the idea that sediment size is going to be really important here as we talk about sedimentary rocks, and when we get into the idea of soil, sediment size is really important. I know it doesn't seem like it, but it's really going to tell us a lot about what the conditions were like when these sediments formed. All right, so we have our sediment, and that sediment is going to travel. It's going to harden, and the word for that is lithify. So lithification is just a fancy way of saying that all these little pieces of rock get stuck together and they harden into a new rock, and at that point, that's when we get our sedimentary rock. And so this is kind of what that idea looks like. We have erosion happening here, where all of this sediment is being taken downstream, and we have the idea of layers forming over here where that sediment is deposited and you get layers forming. And that's basically why sedimentary rocks have these layers formed in them, because it keeps getting laid down layer by layer by layer, and you can see different colors and maybe some different fossils and things like that. So all of that is happening in this stream. It's all erosion and weathering is happening here, and you're getting what's called deposition and lithification. There's some two fancy words for you, which just means it's being laid down and then it gets kind of stuck together and hardened. All right. And that is when we get our sedimentary rock. So here's a few examples of different sedimentary rocks. These are what these guys look like. I'm just giving you a brief overview of this right now. We'll come back and go into these different types of rocks in more detail. All right. Next thing, we get heat and pressure. Heat and pressure is going to cause us to form metamorphic rocks. Well, how do we get that heat and pressure? A lot of that comes from the fact that the crust of the Earth is actually moving around, as you can see in this picture up here. And you can see from this shot that way down here near the core, you have sort of this liquidy, gooey kind of stuff. But as you go up, it gets cooler and cooler and cooler, and you start getting harder and harder rocks, but they're still kind of plastic, we would say. They're still kind of bendy and moldable. So as the crust kind of moves around, it basically squashes these things. And you can see this idea that you start off with something like this, with these nice flat layers from our sediments, right? And then they start getting squished like an accordion or something like that, right? And they kind of squish them together, and you get the deformation here of these guys. And what we get is these layers kind of turning into something like this. And that's when we get that foliation that I was talking about, that banding. And remember, I showed you that picture and it had all these kind of swirly lines in it, right? Well, that's how they get that way. So we go from an igneous rock like granite And when that goes through that process of heat and pressure, it will turn into a metamorphic rock like this one, which is nice. And I think you can see the similarities in colors, and you can see how one would come from another. But this is just like, this is our Play-Doh with lots of little different colors in here, right? And this is actually after we've taken the Play-Doh and kind of squished it around a little bit and got on all those little swirls of colors. All right. After the metamorphic rocks, you get these rocks might get pushed back down into that lower area, what's called the mantle of the earth, and start melting again. So that brings us back to magma, which looks like that. And the magma can get to the surface and become lava. We'll talk about that more later, but the only difference between magma and lava is on the surface where you can see it, magma is underground. And then you get cooling and crystallizing, which you should be thinking minerals right now, right? And that's new minerals, which form, well, new igneous rocks. So, now, I want you to draw a few arrows because you could go right from lava to some igneous rocks. You could go from igneous rocks right to metamorphic rocks. You could get some more heat and pressure on metamorphic rocks. You could go from metamorphic rocks and they could get weathered and eroded and become sedimentary rocks, or sedimentary rocks themselves could get weathered and eroded and become new sedimentary rocks. So it's kind of complicated, right? You can kind of, I don't care if you draw all these arrows exactly the way they're shown here, but I want you to get the idea that it's not just a cycle that sort of starts with one rock and ends up going around in a circle like that. It's kind of complicated, and if you just think about it, the Earth is a complicated place and all these different things could happen, right? Obviously, a sedimentary rock could be weathered and broken down into smaller pieces and then go back through that process again, right? Makes sense that that would happen, and it does happen. Just want you to give you the idea that this is kind of a complex process. All right, so today I still want to talk about one type of rock in more detail. So let's start off with the igneous rock. Next week we'll do the sedimentary and metamorphic, but we're going to start off with the igneous rocks today. So, igneous rocks. These are molten earth that has been cooled. In other words, it's hard lava. So, we have a few different kinds here. We have what's called intrusive, which means they cool very slowly below the crust, and they form really large crystals. I want you to go back in your mind and think about when we've talked about the idea of growing crystals. We did some growing of crystals in class, and I want you to think about the fact that it takes a while for those crystals to grow. So the longer period of time that they have to grow, the bigger they get. Make sense? So if they cool very slowly, like in a very warm place, like underground near some magma, if they're cooling very slowly, they have a long time for those crystals to grow, and the crystals get really big. Those are called intrusive. Think inside the earth. Here's an example of an intrusive igneous rock. This is granite, and you can see these are the crystals here, and they're really big. Right? We can see them close up here. When you think big crystals, I want you to think of crystals that you can see with your eyes, okay? We'll talk about this in a second, but a lot of igneous rocks, you can't even see the crystals because they're so small. They're there, you could see them under a magnifying glass or a microscope, but you can't really see them with the naked eye. Big crystals, like in this granite, are really big and really noticeable with the naked eye. That brings us to our second type of igneous rock, which is called an extrusive igneous rock. And when you think extrusive, think like it exited the earth. This is rock that has cooled quickly on Earth's surface because it's fairly cool on the Earth's surface as opposed to underground where there's lots of lava and magma and things like that. So we have two examples here. We have this one, which is called basalt, and you can see that looks kind of like cooled lava, right? And we have this one here, which is called obsidian. A lot of times they refer to this as black glass because it almost looks like black glass, and you might even have a piece of jewelry that's made out of this. And the key thing here is that because these guys cool quickly, the crystals don't have a chance to grow very much. So they have very small crystals. You can see that you really can't see any big crystals in here like we could see in the last example. And so I want to show you how this works in this next little video clip here.
radiating through his legs. Look at that.
All right, which one's extrusive and which one's intrusive? Can you figure it out? Hopefully you got that. We do have one more because sometimes something happens, like for example, a rock starts to cool underground, but then it gets spit out by a volcano and then it cools really quickly. So you get sort of a combination of large and small crystals, and this is called, this is a tough word, porphyritic. Porphyritic. Okay, so this is a combination of large and small crystals, right? We can see our big crystals here, and this area you can see it's got really little tiny crystals, right? So that means that again gives us a clue to how this formed, because we know big crystals form generally underground and we know small crystals form above ground. So that means that this rock must have started forming underground and then gotten above ground somehow before it completely formed and then cooled very quickly and formed small crystals. Have you ever seen a rock float? How about like this? This is pumice. All of this stuff that you see here is like a little pumice island. And these are actually rocks. And these rocks formed from lava. These are igneous rocks that formed from magma that had a lot of little air bubbles in them. And so those air bubbles form a lot of little holes in the rock, which makes it very light. This is actually an entire huge island of pumice here. There's some more pumice for you. So now, we can classify igneous rocks in another way. Note that before we were kind of classifying based on how they formed. Now we're going to classify them based on what they're made out of. So this is pretty simple. Mafic igneous rocks are dark color and they are very heavy and dense. And a lot of times they have a lot of iron in them, and that's what makes them so heavy and dense. That's an example of a mafic igneous rock. You can see the dark color. There's an example of a mafic igneous rock. The opposite of that would be a felsic igneous rock. These are light colored, they're less heavy, and they're mostly made of silica. So here's an example of an igneous rock that we talked about before. This is granite, and I would call this mostly felsic, but it's kind of a mixture of the two. But we would say this is mostly felsic because it's mostly light color. But I wanted to get the idea across here. We've talked about minerals, and you've seen many different color minerals. In fact, color is one of the ways that we identify minerals, right? And so you can imagine that if rocks are just a mixture of minerals, that you have a little bit of some dark mafic kind of minerals in there, and you have some more light color felsic type of minerals in there, right? So now that we know all about classifying igneous rocks, let's try this out a little bit. Let's practice this. So I want you guys to take a look at these different rocks here. These are all igneous rocks, and I want you to look at the ones in this column right here. So these guys here. And so take a look at this, and do they look like extrusive or intrusive? Well, remember, if we can see some big crystals here, that means they cooled very slowly underground and they are intrusive. And so that makes these guys over in this column here. Notice that they have smaller crystals. I know you can kind of see the crystals in this one, but for the most part, they're pretty small crystals, so they are extrusive. Now let's kind of look at them this way. So these guys are pretty light color rocks, and so would they be mafic or felsic? Yeah, they're felsic. These guys are kind of in between, as we talked about before. They have some dark and some light in them. So we would think of those as intermediate. Intermediate just means kind of in between. They're middle. And these guys are mainly dark color, and so that makes them mafic. All right. Now, I want you to fill all those in on your notes, and along with that, I would like you to fill in the names of all these rocks. So we have granite, which you're probably familiar with. We have rhyolite. We have diorite, we have andesite, gabbro, and basalt. Those are some of the main ones that you're going to have to know. We're going to have to identify these guys in a lab that we do in class. All right, now that you got all those guys, why don't you try this one out on your own? We've talked about this one. This one is obsidian, so you should be able to figure out, is this intrusive or extrusive? And is this mafic or felsic? Please fill that stuff out in your notes. And if you're having a little bit of trouble, well, here's a little hint. This is a pretty cool little animation here. You can see that lava just going right into the ocean. And obviously when it goes into the ocean like that, it cools very, very quickly. And that's actually how you get obsidian. That's why it has such small crystals that are almost non-existent, because it cools instantaneously, and those crystals have basically zero time to grow and become big crystals. So there's your hint to help you out there. All right, there you have it. We're going to be learning about rocks this week. So we reviewed the rock cycle, which you've probably already learned about. And you might remember that it is made up of igneous, sedimentary, and metamorphic rocks. We learned some words like weathering, erosion, and lithification. We learned a little bit of detail about igneous rocks, which are molten earth that has been cooled, otherwise known as hard lava. There are intrusive rocks, which are cooled slowly below the crust and have large crystals. There are extrusive rocks, which are cooled quickly at Earth's surface and have small crystals. And there are the sort of in-between guys that are porphyritic that have a combination of large and small crystals. We also learned to classify igneous rocks based on what they are made out of, which include mafic, which is dark-colored materials, and felsic, which are light-colored materials. Be ready to identify these guys in class, and I'll see you then.